What we're really talking about is an intentional, designed shift away from our dependency on cheap fossil fuels to a time when we're independent of that. And transition is really about seeing that as an enormous opportunity rather than a huge crisis.
We shouldn't project out, with huge projects, but just try things out, trial and error, go in small steps, have diversity, do things locally rather than, transporting energy over wide regions. This is, again, a design problem because, most of our machineries, our buildings, our industrial systems and production systems are badly designed and use a lot of energy.
Key sort of problem in the existing grid really is sort of how we've become used to electricity. So we're used to flicking on a switch and there being electricity there, and we're used to paying for that electricity with just a flat tariff. So we pay electricity per unit, and that's completely different to the actual costs of generating that electricity. So at peak times, electricity is very expensive, it's very hard to produce, you need a lot of capacity, generation capacity that just sits there waiting for that peak time. And then when you move to a grid where it's renewable, you've got sort of wind turbines. If it doesn't happen to be windy that day, then that's a lot of your capacity that's just gone.
When it comes to clean technology, it is in part the opportunity to team up multiple technologies to create new things or new systems or perhaps new paradigms. And doing that fast enough so we take action on climate change, but slowly enough so that we embrace the change. And the beauty, I think, of society today is that there's great awareness and need for change. There are multiple groups in multiple nations, multiple governments basically wanting to take action. Consumers and inhabitants of this earth are saying we must change. And at that magic moment, we have technologies that are good enough, we are deploying.
The key sort of game changer is storage within our homes. So if you've got an electric vehicle, the battery of your electric vehicle will probably run your home for a day or two. So if you can sort of move energy backwards and forwards between your car battery and your home, or maybe you have a home storage battery sitting in your basement, and then you can sort of use energy from your battery when the grid is expensive or carbon intensive, and then overnight when it's clean you can be charging up the battery. As soon as you can store electricity, then the grid doesn't have to look the way it does at all. The grid is designed the way it is because electricity is hard to store.
When we look at total energy calculations, it looks like even if I just deploy the battery in energy demanding situations for just electronics, you probably save 50% of the energy use. Why? This battery doesn't get hot when you charge it, there are very few thermal losses. And the fact that it lasts for a very long time and basically you only make it once. It's very, very nice impact actually that is very beneficial to the world. When I scale up the systems, transport or grid application or energy storage applications, the benefits are 10x. Why? It's because you can launch a new paradigm.
Before the internet, the way that we exchanged it, or the way that information was compiled and exchanged, was very much top-down and sort of centralised. And what the internet's made possible has been that sort of bottom-up, very collaborative, very creative kind of people becoming their own journalists and sharing news and stuff has been fantastic. And so the question would be, well, how can we do the same thing when it comes to localising our energy systems, creating a renewable energy system?
So I like to think that the model of the web is this sort of model of the future grid. So in the web, if I want to put a document on my web page, I don't have to ask anyone to do that. And in this sort of future grid, if I want to sell electricity back into the grid, I shouldn't have to ask anyone to do that. So there should be there's some protocols that my system has to adopt, but it should be a very sort of seamless process. So I think it really does, the protocols and the mechanisms by which these individual homes or businesses or buildings, whatever they are, can actually sort of interact and share energy. That hopefully that really would sort of enable you to build an electricity grid which would be smart, and you'd be building it from the ground up. You could start with 2 homes, then incrementally grow it.
The energy that you have available locally should be used locally as well. It's just much more efficient rather than transporting it back and forth. And what that does, it actually creates a little community. They all become micro-energy companies. Let's say we have an apartment building with solar panels on the roof and maybe a biogas CHP system in the basement. That apartment building is becoming a small energy company with production and consumption and even administration. So the difference is that they're not really a company. They don't feel themselves as a company. They are more a community.
I think we're kind of on a very interesting sort of tipping point with that. You know, we could just end up with an energy system which remains very centralized and which is built around nuclear power and built around large bits of infrastructure that are hugely expensive and which community level wouldn't be able to afford, wouldn't really want to afford, and would have no control or say over? Or are we looking at a much more decentralized kind of energy system with a much higher level of community ownership?
So the smart grid, where more and more people start to have these sort of smart homes, those smart homes can sort of connect with one another, do some of these sort of smart energy services, so demand side management, and actually coordinate with one another. It seems it's a very compelling sort of collection of ideas, and that sort of does sort of sum up the smart grid quite nicely. It's the ideas around the internet and networking and the power of sort of communicating between devices, grounded in the practicalities that electricity physically has to flow. So you can do all this sort of clever trading, but at the end of the day, you have to obey Ohm's law, and electricity will flow where it wants to.
I think the most revolutionary developments are in the lower end, where you reach the consumers. And appliances and everything is going to be smarter because they are going to wonder, what their situation and their surrounding is. A washing machine is going to run when the solar panels actually produce the power. All those devices are going to be much more intelligent, and that's actually where I think the smart in the whole smart grid comes from. Smart grid might not be the right term because it's not so much about the grid, it's about everything attached to the grid that is becoming more smart.
We can certainly create something which is still a national grid, but which is made up of lots of elements that we own and that we manage and that we have a say over, and so that actually generating energy for the national grid becomes a key way of generating energy